In this lesson, we shall focus on mathematics, Euclidean, geometry for grades 11 and 12. We shall look at graded sets of riders, right? A combination of several theorems in actually one geometry question at a time. We shall spend time on the similarity and proportionality theorem and a lot of results and proofs. And we begin as follows. Right, we actually begin by recapping on some of the fundamental aspects of Euclidean geometry, of what we term circle geometry as well. In the diagram, PQ is a common chord of the two circles. Right, I need your attention. PQ is a common chord. What does that mean to say it is a common chord? We understand that PQ is a chord of each of the two circles we have in front of us. Right, so the center M of the larger circle lies on the circumference of the smaller circle. Right, here is the center M of the larger circle, but it lies on the circumference of the smaller circle, as shown in the diagram. I need your full attention to actually analyze this geometry graded set of riders question. P, M, and Q is a cyclic quadrilateral. We take a look. P is this one, right? And we have M there, N there, and Q there is a cyclic quadrilateral in the smaller circle. Well, there it is. We have actually a cyclic quadrilateral in the smaller circle there. Qn is produced to R. Right, we look at Qn. Qn has been produced to R. There is R on the circumference of the larger circle. Okay, we continue to analyze and read through the question, but very, very carefully. Nm produced meets the chord PR at S. Right, we actually are able to see that here we have NM produced meets the chord PR at the point S. The point S is clearly there. Okay. We analyze further. Give a reason why the angle N2 equals X. Right, so we know that the angle P2 is X. We're interested right now in finding the angle, or in actually giving a reason why the angle N2, and there is the angle N2. The examiner is saying, hang on, it is clear that it is actually equal to X, but give a reason why this angle here is exactly equal to X in the question. Right, so there it is. So we are able to remember from grade 11 some of the very, very important results we ever learned. And we know from grade 11, if there is a circle this way, moreover, we actually are able to perform a construction like this. And this is the case. And this angle here is always equal to the angle there. Why is this the case? Right. Right. We continue. So now this is called the exterior angle of cyclic quad, and that is what we state as actually our reason, and we say exterior angle of cyclic quad. Exterior angle of cyclic quad. Exterior angle of cyclic quad. Oh, there it is. So now, if we're able to see that, now we take a look at this here. And we take a look at this, and this goes all the way there. This goes all the way here, like so, and this is sitting there. So we can see, therefore, that the reason why the angle N2 equals X, we actually state that it's because of the exterior angle of cyclic quad. Exterior angle of cyclic quad. Right. Any question? No question.
No, sir.
Okay, good. Forward. I must indicate that you'll try some of the questions. You'll attempt some of the questions as we move along. 10.2.2, write down another angle equal in size to x. We know N2 is already x, and this one is x. The examiner is saying, please do them a favor. Write down another angle that equals x. What is your take? What do you think? Before I give you the answer, you have exactly 2 minutes. 2 marks this question. 2 minutes. What other angle do you think equals x in the diagram? I'm giving you a chance to play around. Are you able to see the diagram?
I can.
Okay, good. So what angle do you think equals x? Once again, you have 2 minutes. Don't rush and break your bones. Don't break your bones. Take your time. If you can't see well, talk to me, please.
So can we say Q1?
Yeah, Q1.
I was gonna say angle subtended by the same.
Because we know that M is the center of the larger circle. A line drawn from the center to the circumference. What do you call a line drawn from the center of a circle to the circumference?
The radius.
Called the radius. Well done. It's called the radius. So first things first, we know that in this case, right, the angle Q1 is equal to what? It's equal to x. The angle Q1 equals x. Why is this the case?
So angles opposite.
Angles opposite equal sides. Angles opposite equal sides. What sides are equal here? Right, it is MP. That is equal to QM. Why is MP equals to QM? Because they are radii. They are radii. Any question?
No, sir.
Okay, we move forward.
Oh, sir, now I have a question.
Yes, please.
I want to ask, can't you just say angles opposite radii?
Yes, you can actually say that, but obviously we are dealing with an isosceles triangle.
Okay.
You can say obviously these are angles opposite equal sides, or you can say the base angles of an isosceles triangle. But you can also say these angles are opposite, obviously radii of the same circle. Right, and there are angles in the same triangle. So that will be correct. Okay, that's correct. Okay,
Yes,
move forward. Move forward. 10.2.3. Determine the size of the angle R in terms of x. The angle N2 equals x. The angle Q1 is also x. The examiner is saying determine the size of the angle R in terms of x. What is this angle here in terms of x? What is the angle there? The angle R in terms of x. Too easy. First things first, we find the angle M1 in terms of x. Right, so now we're looking at 10.2.3 and you say in triangle. in triangle MPQ. Right, let us deal with triangle MPQ. In triangle MPQ, this equals this. Right, so we're able to see that the angle M1 is equal to what? It's equal to 180 degrees minus 2x. Why is this the case? Why is the angle M1 equal to 180 degrees minus 2x in the triangle MPQ? Why is that the case?
Sum of angles in a triangle.
Angles of a triangle. Angles of triangle, or angles in a triangle, also correct. Right, so now we want to find the size of the angle R. So what is the size of the angle R? If we already know that this angle is 180 degrees minus double x, what is the size of the angle R? Okay, obviously we know that the angle M1 is equal to what? It's equal to twice the angle R. Why is this the case? Angle
So
at
angle at the
center.
center is
Yes.
2 times.
Well
So
done. Yes.
can you please highlight the shape, because I'm struggling to see the angle at the centers 2 times.
Okay, yeah, okay, that's fine. So you have this shape here in the larger circle, and you have exactly this here. Right, so yeah, definitely. So it is clear, therefore, that the angle at the center is actually 2 times the angle at the what? At the circumference. 2 times. So the angle at center equals 2 times angle at circumference. Circumference. Right. So what do we have here? Okay, at this point, we know that angle M1 is twice R, which means the angle M1 is 180 degrees minus double X, which equals twice angle R. Dividing through both left and right by 2, it means that the angle R is, if you divide 180 by 2, you get a 90 minus X. Right, so we're to determine the size of angle R in terms of X, and we can see it is actually precisely 90 degrees minus X in geometrical size. Any question?
No, sir.
No question. We move forward. We move forward to the next question. Next, we want to prove that PS equals SR. Want to prove that PS equals SR. PS is equal to SR. Want to prove this. To prove that PS is equal to SR, where do we start? And what do we do? In which triangle do we work? What do we do?
So can't you prove that S1 and S2 are equal? Or
Yeah,
wait, I'm trying to see.
Yeah, that's fine. That's fine. Take your time. 2 minutes. I give you the time. 2 minutes. And then we shall do it together. We shall do it together. Don't stress too much. I just want you to think about it first, because now you're going to meet it in the prelims. This kind of a question. But this is all very, very basic grade 11 stuff. Euclidean theorems, and then we shall look at similarity and proportionality. But this is just a warm-up. Because before we do serious things, we must first warm up. The players in soccer, before they start playing, what do? They first warm up. Because when they're sitting down, the body becomes cold and the muscles become relaxed. Now they try to tone the muscles to energize themselves. Right, want to prove that PS equals SR. I want you to think about it and then suggest what we need to prove to have exactly that result established. I know it's too easy. I know it's obvious, but we need to work on it together. It's already sitting in front of you. It's already watching you. But I don't want to tell you, because if I tell you, then you're like, okay. Then you never learn to think, you see. And that's a problem. Children must be taught to think. Geometry is about reasoning. 1 minute left. 1 minute.
So the only thing that I see that they share in common is the angle is. That's the only thing that I see that they
Yes.
share in common. Besides
Yes.
that, I don't.
Okay, that's fine. That's fine. Never mind. We're not here to crack your skull. We're here to train you. You have to make sure that you become the best you can be. Let us reason together. Let us reason together. Now to start with here, because this is way too obvious, we're going to work in triangle. So we're doing 10.2.4. We're going to work in triangle N, SR. Shall work in triangle N, S, R. There are certain things you already know. Like we know the angle N2 is what? It's X. X. 90 degrees minus X is the size of the angle R, because that's what we said. We said R is 90 degrees minus X, like so. Upon careful examination, we already have the answer, but we must put the answer in order. Mr. Examiner, we know that angle R is 90 degrees minus X. And we know that the angle N2 is X. That we know. We know that this one is 90 degrees minus X, and we know that this one here, N2, is actually X in size. So it remains to find the size of the angle S2. Right, so we can see that the angle S2 is 180 degrees minus the other two angles, because it's the only one we want. So it is 180 degrees minus 90 degrees minus X, but minus X as well, giving us the angle S2 equals 180 degrees. $180. Okay, yeah, this is 90 degrees minus X. Anyhow, we need to put a plus here, because it's 180 degrees minus this angle together with this. Minus 90 degrees minus X plus X, which gives us 180 degrees minus 90. And then now this is actually plus X minus X. The angle is 2. So 180 minus 90 is 90. 90 degrees. And this is what? The reason for this here, angles of of triangle. Angles of triangle. So in other words, we've been able to establish that in fact, what we are sure of is the fact that the angle S2 is 90 degrees precisely. Like this. Now the angle S2 is exactly 90 degrees, like so. And therefore, PS is actually equal to SR. PS is SR. Why is this the case? Line from center. Line from center perpendicular to what? Perpendicular to chord. Line from center perpendicular to chord. Okay, that's a grade 11 theorem. Line from center, because M is the center, that is perpendicular to the chord, bisects the chord. So because we showed that the angle S2 is actually 90 degrees, it must follow that the angle S2, therefore, what it does is it bisects the chord. Any question? No question.
No, sir.
Move forward. We move forward. Right, here's another question. Yet another geometry question. Very, very interesting. And we're back to some of the basics of geometry. Right. O is the center of the bigger circle. We can see that O is the center of the bigger circle. Now, O lies on the circumference of the smaller circle. There is O on the circumference of the smaller circle. OWVU. OWVU are points on the circumference of the smaller circle. You can see the O, the W, the V, and the U are like points on the circumference of the smaller circle. TSVU. TSVU are points on the circumference of the bigger circle. You can see the T, the S, the V, and the U are on the circumference of the bigger circle. Name 4 other angles each equal to X with reasons. Right. There it is.
So I think I found them.
Okay, which one do you think is the case? First,
S1.
the angle
is equal,
S1. Well done. The angle S1 equals X. Why?
angle at the center
Center.
is equal to 2 times angle at the circumference.
2 times angle at circumference. Next.
And then V is equal to X.
The angle V. Which particular V? Is it the whole of V?
V3, sorry, V3.
V3 equals X. Well done. So S1 is already X. V3 is X. Why would V3 be X?
Angles subtended by the same chord.
Angles subtended by the same chord or angles in same
segment.
Same segment. Next.
And then the whole of U1 plus U2 is equal to X.
The whole of U, which is U1 and U2. So in other words, the angle U equals X. Why would this be the case?
Because of angles opposite equal sides radii. Yeah.
Opposite equal sides radii. Okay. Yeah. So now, which triangle are you looking at? Okay, obviously you are right. So in other words, because O is the center of the bigger circle. Right, so that is correct to then say if O is the center of the larger circle, these are radii. Right, so we have exactly that. That at this point, what are you able to see? You are able to see clearly that you have angles opposite equal sides. What are the equal sides? Right, so you're able to see that OV is equal to what? OU.
OU.
What are these? They are radii. Okay, right. That's correct. Next.
And then I'm thinking V1 is equal to X because it's exterior angle of the cyclic quad
Which one?
WOUV. The cyclic
WOUV. Yeah, it looks that way. Yeah, but a little bit different. What other
yeah.
angle? Another one?
I was thinking V1. I'm not sure as well.
Right. Yeah,
Oh,
but
so T
yeah.
T T
You
T
think the angle T. Okay, that's fine. Remember, we're learning, so there's no haste here. You think the angle T, why would T be X?
because it's angles in the same segment as well.
Angles in the same segment. But need to look at it carefully. Because if you look at angles in the same segment, you need to look at T like this. And then it would be angles in the same segment if the X was this.
Oh, okay.
But now
I see it.
it's a bit too big. Because it was supposed to be here. Like that, something like that. You know? But now this U1 is now taking a little bit, something outside.
Okay, I don't think I know the other one, but yeah.
Okay, thank you for trying. Thank you for trying. That's what makes the lesson. Right. However, we are able to see that clearly the angle W1 and the angle V3 are nice angles. The angle W1 okay, we continue. All right. Okay, let's continue. Right. I was mentioning another angle in particular when I just paused a little bit. We're looking at the angle W1 is the angle V3, which equals X. Why is this the case? The angle W1 equals angle V3, which equals X. Why? Do you agree that angle W1 equals angle V3?
Yes, sir.
Why?
Because the angles in the same segment.
Angles in same segment. So we have mentioned 1, 2, 3, 4 angles, each equal to X. Right, that's awesome. Good news. Let's continue with more problems. Determine right now the size of the angle W2. Determine the size of the angle W2. So we found like V3 is X. You're seeing that this one is X. We've seen that the whole of U is X. You have seen that this one is X. Determine the size of the angle W2. What do you think? Right. Okay. Okay, we continue. We continue. Right. Okay, yeah. What do you think the angle W2 is equal to in terms of X?
Sir, I don't know,
Yes.
sir. I'm not sure actually.
Because here is the question. That is 10.2. 10.2 says determine the size of W2 in terms of X with reasons.
Oh, So
Yeah.
isn't
So
it
we need W2. Yup.
on opposite side of a cyclic quad equal to 180? So
Mhm.
W2 is 180 minus 2x, if I'm not mistaken.
Okay. Yeah. It sounds very opposite angles of a cyclic quad are supplementary, and therefore their sum is 180 degrees. So what do you then think here?
So I'm thinking that W2 is equal to 180 minus this x minus x
Okay, you think
minus
that
u
W2 is 180 degrees minus what?
minus minus 2x. That's what I'm thinking
Why?
it equals.
Why?
Because if the opposite sides are supplementary and we know that u is x and
Yes.
w1 is x, then in order to find w2 you have to minus the 2 by
Mm-hmm.
180.
Mm-hmm.
I don't know if you hear me. Yeah.
Yes. Okay. Yeah. What do you think the size? What is the size of the angle O2?
Of O2.
Yup. This one.
So O2 is equals to 180 minus x as well. Minus 2x as well.
180
Because
degrees minus 2x. Why?
because it is, oh, I see. Okay. Yeah. 180 minus 2x because of sum of angles in a triangle. So angles in a triangle.
Angles in a triangle. Good.
And then O2 sub
So you know this one is 180
O2
degrees minus 2x. Yeah.
O2 and W2
So
are
W2
angles in the same segment.
W2 is equal to the angle O2, and it is equal to therefore 180 degrees minus 2x. Why?
Angles in the same segment.
Angles in the same segment. Well done. Angles in the same segment. Angles in the same seg. Then say that. Angles in the same seg, and the examiners know that. Angles in the same segment. Like so. We're good. Next.
Yes.
Right, so we actually obviously have established the size of the angle W2 as also 180 degrees minus double x. What is prove that WS is WV? Prove that WS is WV. Right, so yeah. Here it's WS. Prove that WS is actually WV. WS is WV. You want to prove that these are equal to each other. And I know that you've already, it's too easy. It's already too obvious.
So I know the angles that we're supposed to be proving.
Okay, which angles are we supposed to prove?
We're supposed to prove that V1 is equal to S2.
We're supposed to prove that V1 is equal to S2. Is it? Okay, that's fine. That's fine. Yup, that's correct. We are pretty much there within the vicinity of what we expect to do. Yeah, let's get cracking.
So S2 is equal to O2 because they're subtended in the same segment. So it's going to be 180 minus S2 is equal to 180 minus 2x.
S2 is 180 degrees minus 2x. Why is that the
Yes,
case?
because they're in the same segment.
They're in the same segment. S2 is in the same segment with which angle?
O2.
The angle O2. Okay, but you see, obviously, I mean, they must be on the circumference of the same circle. S2 is an angle on the larger circle, but O2 is on the smaller circle.
Oh, they have to be, okay, I see it.
I hear you. but angles in the same segment, it must form like a bow tie on the same circle. But yeah, I can see O2, it looks like it's in the same segment, but yeah, it is on the smaller circle, then that one is on the larger circle. Next, what do you need? Okay, there are a couple of things you're able to see, like the angle S1 plus S2 equals 90 degrees. This angle is 90 degrees. Why?
Angles, something semicircle. I forgot
Okay.
the reason. There's something to do with the semicircle.
Okay.
Yeah, the line here makes it a semicircle to 180.
Yeah, definitely. That's an angle in semicircle.
Yeah.
Why?
So because TV, the chord TV is equal to 180. The angle is equal to 180, and since it's, I don't know how to explain it. The angle,
Okay. Yup.
2 times angle in the circumference, basically. But
Okay, that's
because
fine.
TV is
Yes.
180.
Okay, I hear you. I hear you. So the angle S2 is equal to what? The angle S2 equals what? Because you already know that S1 is X. So S2 would have to be exactly what? Would have to be exactly 90 degrees minus X. So this one is 90 degrees minus X. V1. What is the size of the angle V1? Okay, now we want to find the size of the angle V1. But you already know the angle S2, which is 90 degrees minus X. Yup. And what else do we know?
So V1
Yeah.
is the same. I feel like V1 has the same reason. No, it doesn't have the same reason. Never mind.
Okay. Okay, that's fine.
It looked
That's
like it had the
okay.
same reason because of SW. WS.
Mm-hmm.
I thought maybe because of that it would have.
Okay, you got this one. We got this one to be X. You also got this one to be X. We got this one to be 180 degrees minus double X. But we also got W2 to be 180 degrees minus twice X. So what is the size, therefore, of the angle? Right. So what is the size, for instance, of the angle W3? Right. So you need to think. Yeah, the size of the angle W3, or for example, the size of the angle W2 we know very well, and then we know the angle S2 as well. Can we be able to get V1?
So I found W3 as minus 2x.
Please come again.
I found W3 as minus 2x because SU is a straight line, so angle on a straight line W
So that would mean that W3 is equal to what?
minus 2x.
Or just 2x?
Minus 2x
Why?
because of angles on a straight line.
Okay, that's fine. I want us to test this. Okay, what can we add? Because they must add up to 180, the W3 and W2. So if this one is already 180 degrees minus 2x, what can we add to these to get 180? So when we have 180 degrees, yeah, minus 2x, what do we add? If we add 2x, what do we get?
180.
Yeah. Okay, so take a look. Okay, yeah. So the angle V1 would be Okay, that's fine. You can just say, for instance, doesn't matter. You can say, for instance, please, your now the angle W3 is equal to 2x. Why is that the case?
So angle on a
Yeah,
straight line.
angles on a straight line. Angles on a straight
Yes.
line. If you add these, if you add the 2x to these, you get exactly 180. Right? So that's what we have. So this one here, these are angles on a straight line. Right, so this is the case. The W3 is actually 2x because of that. Therefore, the angle V1 is equal to what?
V1 is equals to 90 minus x.
Yeah, so
And then
W2 is 180 degrees minus 2x. This was proved. It doesn't matter. You can say that it was actually most certainly. Yeah, it was proved. Yeah, it was proved here. It was proved in 10.2 above. All right. So yeah, next.
and then you say V1 is equal to 180 minus open brackets minus 2x plus 90 minus x.
Okay. All right. So that's what we have. But yeah. So now, okay, yeah, the W2 it's there. What is the size of the angle V1 now?
V1 is 90 minus x.
Yeah,
Oh wait,
61. Yeah, that's fine. You're right. So how do you know it's 90 minus x? Maybe that's what you need to ask. How do you know?
okay. 180 minus
Minus 2x minus 90 degrees minus x, which is 180 minus 90 degrees. And then this one is x, and this is minus x. 90 degrees minus x. Okay, so if that is the case, therefore SW is equal to WV. And the reason for that is sides. Okay, I can write it the way it has been given. You can say, therefore, WS is WV, and these are sides opposite equal angles. Sides opposite equal angles, right? Okay, we've proven that WS equals WV. Any question?
no sir.
Okay, we move forward. Right, here's something easy. In the diagram, MP is the diameter of a circle. Yeah, right, here it's M and there it's P, the diameter of a circle centered at O. O is the center. MP cuts the chord NR at T. Right, we can see T there. Radius and O. And chords PR and N and MR are drawn. The angle R1 is 69 degrees. The angle R1 is 69 degrees. The angle R1 is 69 degrees. Right, determine giving reasons the size of the angle R2. Okay, we're reversing some of the basics. Why would this be the case? Okay, yeah. Want to find the size of the angle R2. What is the size of the angle R2? What do you think and why?
So we can
Yeah.
see that the whole angle R is equal to 90 degrees because of
The whole of
angles
angle R is 90 degrees. Why?
of a semicircle.
Angle R equals 90 degrees, and the reason is that we have angle in semi. Semi what?
Circle. So R2 is equals to 90 minus
2
69.
equals 90 degrees minus 69
69.
degrees. Why? Okay, yeah, well, so it's obvious. It's obvious. Right, so that the angle R2, okay, what is 90 degrees minus 69?
21. 21.
Exactly 21 degrees. Exactly 21 degrees. Next, want to find the size of the angle O1.
O1 is equal to 2 times R1 because
Angle
of
O1 is 2 times the angle R1. Why?
because angle in the sense is 2 times angle at the
Angle at
circumference.
center equals 2 times angle at circumference. Right, angle at center is 2 times angle at circumference. And therefore, the angle O1 it's double 69, 138 degrees.
Yes, sir.
Right, enter YAR. And the reason for the substitution is that the angle R1 is actually exactly equal to 69 degrees.
Yes, sir.
Okay, yeah.
And then, yeah.
Yeah, so what do you think? Yeah, so this is O1. O1 is okay. 138 degrees, and we've got it. We've got it. We move on to the next question. What is the side of the angle M1? This one here.
M1 is equals to R2 because
M1 equals R2. I agree with you. I agree with you. The angle M1 equals the angle R2, which equals what?
21.
Which equals 21 degrees. Why is that the case? Why is M1 equals R2? Why?
Angles in the same segment.
Angles in same segment. Angles in same segment. Move on next. We want to find the size of the angle M2. What is the size of the angle M2, for example? Yeah.
So, I'm not sure, but I'm thinking about using the thingy, the fun angles, the
You're
alternating
using the
corresponding
fan.
and
Okay,
cointerior
yeah. So, okay, we want to find the size of the angle M2. Yeah.
because they want us to prove that it given that NO and PR are parallel. Wait.
Okay. Okay, yeah,
So I'm not
we want to find the size of the angle M2, right? Want to find the size of the angle M2.
so
Yeah.
I think we found the angle O1, which is equal to 138.
Yes.
find the angle of O2 because
Find
of
this
angle.
one, 138 degrees. Yeah. So what is the size of the angle M2?
So, we find O2, right?
Yeah.
And then O2 is 180 minus 38, which gives us 42. That
Yeah.
makes P 42 because NO and PR are parallel since it's given to us.
Okay, because NO is parallel to PR. Good.
Then so P is also equal to 42. Then in order to find M2, you say 180 minus 19 minus 42.
Yeah. So you really are on point, and it makes a lot of sense. So that what we have here, so the one find the size of the angle M2. Right. So now you saw that this is parallel to this. So what do you think the angle O2 is?
O2 is 42. It's 180 minus 138 because of angles on a straight line.
Okay. Right. Okay, we continue. Okay. Okay. Okay, we continue, please. Yeah, I'm still here with you. Okay, so all right. What are you saying? What did you say angle O2 is?
42 degrees.
It is 42 degrees. Okay, so the angle O2 is 42 degrees. Okay, that's fine. Okay. Okay, we're here. We're here. Okay. Okay, look. The angle O2 is 42 degrees. Why? Because what is the reason?
Angles on a straight line.
Angles on a straight line. Right, we are right. Angles on a straight line.
And angle P is also 42, alternating
So
angles.
now, then this one you can see is 42 degrees, and therefore the angle P is equal to 42 degrees. Why? Because of the alternate angles. Why do we have alternate angles? Because they're parallel lines. What are parallel lines? NO is parallel to
PR.
Okay. So we have that this one is 42 degrees. Then what is the size of the angle M2?
M2 is 180 minus 90.
180 degrees minus 90 degrees minus 42 degrees. Is it correct?
Yes, sir. It's
So what
48.
is the answer? It is
48.
exactly 48 degrees. Why is M2 equals 180 degrees minus 90 minus 42? Why?
Because of angles in a triangle.
Angles in a triangle. Angles in a triangle. All right, so any question?
No, sir.
No question. So we move on to the next one. Right, so in the diagram below, ABCD is a cyclic quad. But also A, B, and D, C are produced to meet at E. AB and right, and obviously your DC are produced to meet at E. AD and BC are produced to meet at F, and that is F, and we have that the angle AFB is 2x. Right, so the angle AFB is double x, there it is. The angle DAB is 3x. There it is. Your DAB is 3x. And the angle AED is x. AED is x. Determine giving reasons the value of x. I'm giving you 2 minutes. Then we shall do it together. Some 2 minutes. Then we shall do the corrections. Right. Okay, you have 1 minute left. Right, how far? How far?
So I'm almost done.
All right. Then we shall do corrections when you're done. Okay.
Yes, sir. So I'm done.
Okay, what did you get as the answer?
Should I give you the straight answer or guide you?
Yeah, the straight answer first, and then I'll look for the steps.
So I got x is equal to 20.
Well done. X equals 20 degrees. Okay, yeah. I mean, you're really on point. So the couple of things that you can see, because I agree with you there. There is this one from grade 10, so 20 is correct. So now from grade 10, we know that the angle D1 is actually equal to x plus 3x, which is 4x. And this is exterior angle of triangle. Exterior angle of triangle. The angle D2. Okay, if this one is 4x, therefore the angle D2 is 180 degrees minus 4x. Angles on a straight line. Angles on a straight line. So that this one is 180 degrees minus 4x. Right, so that's what we have. Next, we have that the angle B1. Right, the angle B1 also from grade 10. The angle B1 is 3x plus 2x, which is 5x. Why is this the case? Exterior angle of triangle. So that, okay, so we have that this one is 5x is equal to this. So that the angle B1 is D2 exterior angle of cyclic quad. The B1 is 5x. The D2 is 180 degrees minus 4x. So that now you say 5x and that which is 9x is 180 degrees. So you divide by 9. You divide 180 by that, you get 20 degrees. So well done to you. 20 degrees is the correct answer. 20 degrees is indeed the correct answer. So because we had to determine, giving reasons, the value of x, and we found the value of x to be exactly equal to 20 degrees. Yes, please.
So I did it differently.
What did you do?
I looked at ADE as its own triangle, and
Yeah,
ABF as its own triangle,
yeah.
and then I solved for B2 and
Okay,
D2,
okay,
and it
okay, okay. Let's look at that together. So you looked at ADE as its own triangle.
yes, sir.
Okay, in triangle
Mhm.
ADE. So what did you do? Is the one with ADE?
Yes, sir. So since we know that, since we have the two angles, I said,
Yeah.
okay, D2 is equals to 180 minus 3x minus x.
D2 equals 180 degrees minus what?
3x minus x,
Which is equal
and
to?
then 180 minus 4x.
Yeah.
And then I did the same with ABF to find B2. I
So
said
you did
B2
the
is equal.
same in the triangle ABF.
Yes, sir.
Right. So what do you
I,
get? The angle D2, the angle B2, right?
yes,
Which one?
sir.
Which one?
Is
Are you
equal
sure
to
B2?
1
Yeah, 180.
B2 180 minus 2x minus 3x.
Okay. Which is 180 minus what?
And then it gave me 180 minus 5x.
Okay, so
And then I
B2 is
equated,
180 degrees minus 5x, and this one is 180 degrees minus 4x. Yeah.
then since we know that the opposite angles of a cyclic quad is this, the angle supplementary, then I said that 180 minus 5x plus 180 minus 4x is equal to 180.
Good, good, good.
And
Yeah,
then
B2, yeah.
solve for x.
Yeah, this
And
is
then I
tricky
solve for
because,
x and I got
yeah. Okay. So the 180 minus, it's 180 degrees minus 5x. 180 degrees minus 4x equals 180 degrees. And therefore, the 180 degrees is going to cancel one of these, giving us exactly equals 9x. Okay, yeah, and the x is 20 degrees, correct? Okay, good. This is
yes, sir.
correct. This is correct. So in this case, you would say the 180 degrees minus the dt equals 180 degrees minus. So the reasons for these obviously are that angles in triangle, but also this one here, angles in triangle. Okay, so we're good. Okay, so we're good. All right, so, all right, so you continue. Next point. Right, we move to the next question, right? Right, let's look at this one. In the diagram, TSR is the diameter of the largest circle having center S. Chord TQ of the largest circle cuts a smaller second at M. PQ is a common tangent to the two circles at Q. SQ is drawn, right? SQ is drawn, but moreover, RP is perpendicular to PQ. RP is perpendicular to PQ, but also the line segment MS is parallel to QR. MS is parallel to QR. Proof giving reasons that SQ is the diameter of the smaller circle. We need to prove that SQ is the diameter of the smaller circle. How do you prove that SQ is the diameter of the smaller circle? What are we supposed to look for? What do you think? You have 2 minutes.
So I think we need to find M2 as an angle. And then from M2 you can say angles opposite angles at the angle at the center 2 times angle at the circumference. Angle at the center.
All right, that's fine. That is okay. That's all right. So let's take a look.
Sorry, sir, for the noise. My
That's
mom walked
fine.
in.
That's fine. That's fine. So now, right, you were saying something, and yeah, please come again. Please come again.
So I was saying, sorry, I thought I was unmuted. So we need to find the angle of M2.
Right, you need to find the angle M2, right? Correct. So what do you think the size of M2 is?
So the size of M2 has to be 90 degrees, but I'm not sure about the reason.
Okay, yeah, that's correct. The size of M2 must be 90 degrees, yeah, so that SQ therefore becomes the diameter, and therefore it would mean that SQ subtends an angle of 90 degrees at the circumference of the circle. Right, so we wish to find the size of the angle M2. Let us find it. I agree with you, it must be 90 degrees, but why? because we know, yeah. Okay, let me hear what you have to say.
I'm not sure. So I was gonna say I'm not sure. Oh, so um, okay, never mind. It's not gonna work. Never mind. Yeah.
Okay, that's fine. Okay, because it's about practice. Okay, we're practicing here. But now this angle here, because S is the center, is the center. S is the center of the larger circle. So this line here is the diameter that is passing through the center. And if it is the diameter, therefore the diameter subtends an angle of how many degrees of circumference? In other words, we are effectively then saying the angle Q1 plus the angle Q2 is 90 degrees. Why? Because it's an angle in semicircle. Angle in semicircle. Right, so it's an angle in semicircle. Right, so, okay. Right, so we have that this angle here, Q1, Q2 is actually exactly 90 degrees. Next. So that the angle M2 is actually therefore equal to 90 degrees. Why?
Co-interior angles.
Because these are co-interior angles. Well done. They are co-interior angles. Why? What are the parallel lines?
MS is parallel to
MS is parallel to QR. Next. Okay, yeah, then therefore SQ is a what? It's a diameter. SQ is the diameter. Why is SQ a diameter? Converse. Converse angle in semicircle. Converse angle in what? In semicircle. Converse angle in semicircle. Converse angle in semicircle. Any question?
no, sir.
No question. Right, we move on. Similarity and proportionality. The prop theorem is next. So obviously in 10.1.1, we have proven that SQ is the diameter of the smaller circle. SQ is the diameter of the smaller circle. We've proven that. 10.1.2. Right, we need to prove right now that RT is RQ squared over RP. Right, so at this point, to actually prove this, we decide the triangle in which to work. So now we have RT, for example. RT, because we need to prove that RT is RQ squared over RP. In which case, therefore, in this result, we have exactly RT, but we also have RQ, we also have RP. Okay. The question is, in which triangle is it going to work? We're going to work in triangles. Triangle RTQ. And triangle RQP. Right, now, first things first, we're going to have that so when I work in triangle RTQ and triangle RQP, the angle T is equal to the angle Q3. The angle T equals the angle Q3. Why? Or you can start, yeah, that's fine. The angle T equals the angle Q3 because we know that QP itself is a common tangent. PQ is a common tangent, and therefore this is the Tan-Chord theorem. Tan-Chord theorem. So that then Q1 plus Q2 is 90 degrees. Q1, angle Q1 plus the angle Q2 equals 90 degrees. Why is this the case? Q1 plus Q2 is 90 degrees because we have an angle in semicircle. Right, so, yeah, we have that. The angle P is 90. In other words, therefore, the angle Q1 plus the angle Q2 is 90 degrees. Okay, yeah. Is equal to the angle P, which equals 90 degrees. Why? Because these are both equal to 90 degrees. So these two angles, Q1, Q2, and P are both equal to 90 degrees. Now we have a remaining side for the remaining angle, the angle R1, the angle R2. So the angle R1 is equal to the angle R2. All right. So the angle R1 equals the angle R2. Why would this be the case? R1 equals R2, angles of triangle. Angle R1 equals angle R2, and these are angles of triangle. Okay. And as a consequence, we're able to see, therefore, that we have that the triangle. So therefore, the triangle RTQ is similar to the triangle RQP. Okay? Because of angle, angle, angle. Angle, angle, angle. As a consequence, what we're able to establish here is therefore the fact that you can take RT over RQ. You can take RT over RQ. In other words, you can take RT over RQ is equal to RQ over RP, and then it is equal to TQ over QP. RT over RQ is equal to RQ over RP, TQ over QP. So that in the end, okay, so we have this. So that now we have RT. You cross multiply. Right, if you cross multiply, then in this equation, you're going to take the first two. Right, we have RT is equal to the RQ, which will give us RQ squared over RP. All right, and that is the result. And that is the result.
So can you,
Yes.
I'm sorry, my Wi-Fi disconnected. Can you like
Oh,
repeat
repeat. That's fine.
from R1 is equal to R2? I think that's
Okay,
when it
okay,
started.
that's fine. Yeah, R1 equals R2. You see, the thing is that we are dealing with a triangle RTQ, and the triangle RQP. And then we already have that first Q3 is equal to T. In other words, we're dealing with this triangle here. But you can see that Q3 is equal to T. But also this angle is 90 degrees as much as this one is 90 degrees. So that now we're only left with R1 and R2 in these two triangles because this angle equals this and this is 90 and that is 90. So R1 must be R2. Why is R1 R2? Because these are angles of a triangle, like the third angle that is remaining in each of these triangles. Right, so as a consequence, therefore, is that the triangle RTQ is similar to triangle RQP because we have angle, angle, angle. Angle, angle, angle. And then now we actually therefore are able to see that we have taken this in order in the following way, such that the angle R equals angle R, the angle T is equal to angle Q, T equals Q, and Q is equal to P. Q equals P. Q equals P. So these are in the right order. And if they're in the right order, then we can take the right proportions and then say RT over the first two over the first two. So RT over RQ is equal to, for example, RQ over RP, which equals TQ over, for instance, QP. Right, now if you cross multiply, so that RT is RQ squared over RP. Right. So, yeah. Yeah, any question?
Proportionality again, because
Okay. Oh,
I understand, but I don't understand to the extent where I could do it by myself.
okay. Are you suggesting that
Yes.
we do another question?
No, we can do another question, but I was just suggesting that we reteach proportions and
Okay.
top theorem and how it works.
Oh, okay, that's fine. Okay, that's okay. We shall discuss it. All right, that's fine. And we continue. Right, so the proportionality theorem now has been applied here. In 10.2, the question is, if MS is 14 units, MS is 14 units, PQ is the square root of 640. Calculate giving reasons the length of the radius of the larger circle. Calculate giving reasons the length of the radius of the larger circle. Right, so in other words, we want to find the radius. If S is the center, therefore we want to know the radius, either TS or, for instance, SR. But there are a couple of things that we most certainly already know. So in other words, one can actually look at this and say, we need, for instance, RS, right? But we can first be interested in knowing that, for instance, RT from the previous question RT is equal to RQ squared over RP. So we take that. RT is RQ squared over RP. RQ squared over RP. So this one was proved. It was proved in 10.1.2 above. Right, so MS is what? MS is 14 units. And then QR. Now QR is exactly 28 units. Why would QR, if this is 14, QR is what? Okay, because if this is 14, but S is the midpoint, from grade 10, there's something we call the midpoint. Midpoint theorem. Right, something we call the midpoint theorem. Midpoint theorem. Right, so that this one is 28 units. What is RP squared? What is RP squared? Right, so in the case of RP, you can use Pythagoras theorem because this is like the hypotenuse. So RP is a side, so that RP squared is 28 squared minus 28 squared minus the square root of 640 by Pythagoras theorem. 640, and you square this. Pythagoras. So that we have RP squared is 144, and you take the square root of RP squared, the square root of 144, and then you have RP, the square root of 144 is 12 units. So we found that RP is 12 units. Right, so in other words, now we're back, and we have this particular result here. So RP is 12, RQ is what? 28. So we're done. Divide like this and then say hands. This is actually exactly RQ squared over RP. What is RQ? Or QR? RQ is already 28 by the midpoint theorem, because already if this triangle, a line segment that joins the midpoint of two sides of a triangle, is equal to half the third side equals, also it is parallel the third side. So that RQ is 28. RP is 12. So that in the end, if you simplify these things, you get 196 divided by 3. That is RT. So you get that the whole of RT is exactly 196 divided by 3. But we want the radius, because now the RT is like the diameter, so that radius is half RT. The radius is half of the diameter. Half RT, what is RT? Is 196 divided by 3. 98 divided by 3 units. 98 units. 98 units. Any question? Because we had to find the length of the radius of the larger circle, and we found the radius by taking half the diameter RT, and therefore we got the answer. Any question?
No, sir.
Okay, pretty clear. Okay, we move on to the next one. Move on to the next question as follows. Right, more proportionality theorem here. Right, in the diagram, M is the center of the circle. M is the center of the circle. There it is. A, B, and C are points on the circle such that AC equals BC. We have that. Exactly AC equals BC. PA is the tangent to the circle at A. Right, at the point A, you can see that PA is the tangent. PQ is drawn parallel to CA. Okay. To meet BA produced at Q. BC produced meets PQ at R. And AR is drawn. Let the angle Q be equal to X. Determine giving reasons 4 other angles each equal to X. We start again. 4 other angles each equal to X. Okay. There we go. There we go. What do you think is the next angle that is equal to X? If Q is X. What do you think?
So what does
Yes.
the can I ask, what does the Tan-Chord theorem say about the 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 lines
Definitely. So the
equal to?
Tan-Chord theorem says that the angle between a tangent to a circle and a chord equals the angle in the alternate segment. So the angle between a tangent to a circle and a chord, this angle equals the angle subtended by this chord. This chord that makes the angle with the tangent subtends an angle in the opposite segment.
So there's other one that states something about the lines of a tangent coming from the same point are equal
Oh,
or something.
yes. Yeah, tangents drawn from the same point outside a circle are equal to each other. So if you have that these two tangents are drawn from the same point outside a circle, they're equal to each other, right?
Okay.
That's when you are seeing like two tangents, like a tangent there, the blue one and the red one,
Okay.
And if they're drawn from the same point, like they're drawn from the same point outside the circle, then they're equal to each other. Yeah?
Yes. No, I was just refreshing my
Okay, that's
memory.
fine. That's okay. So we're right back in business. We want four other angles each equal to x. Determine given reasons 4 other angles each equal to x. What do you think?
So we can't say that we can't say that Q is equal to P.
Okay. Yeah, I mean, that'd be very interesting, but why?
That's the thing. I don't know why.
Okay. Yeah, it'd be very interesting to see. But yeah, I mean, if we know that PA is a tangent because they said here PA is a tangent to the second at A. But what other tangent is there? We're not told. We're only given like one tangent. Okay. So what do you think? What do you think? We're not in a hurry. We are not in Harare, Zimbabwe. We're not in Harare, where maybe there's, a haste and a hurry. People are in a hurry. No, we are relaxed. We are chilled. That is the slang. We're chilled. So yeah, chill is the contemporary slang. The question is, we need 4. Determine giving reasons 4 other angles equal to x. Angle Q is x, but 4 other angles equal to x. Okay, we go back to grade 10 and we can see. Because this one is parallel to this one is parallel to this one, and therefore these angles here, the angles in F like this, so this angle is x, and this one is going to be x. X, x. And these are the kinds of angles we want, and these are corresponding angles. The angle A1 equals x. The reason is that we have corresponding angles. Why corresponding angles? Because they have parallel lines. What are the parallel lines? PQ is parallel to CA. PQ is parallel to CA. PQ is parallel to CA. Next. Right, so obviously it follows therefore that this angle is also x. What is the next angle that is equal to x? Obvious. The next angle that is equal to x,
B
what
is
is it?
equal to x. B is equal to x.
B equals x, well done. B equals x, y.
Angles opposite equal sides.
Angles opposite equal sides. Next. Another angle equal to x. Another angle equal to x. Okay. Another angle equal to x. What is it? Yup. Another angle equal to x. What is it?
I don't think I can see the other ones now.
Okay, from grade 11. The angle between a tangent to a secant and a chord equals the angle in the alternate segment. So there's an angle between a tangent, PA, and a chord equals the angle subtended by this chord, and this chord subtends the angle x, so also A2 is x.
So, and then the other one, P is also equal to x, then alternate angles.
Well done. Well done. P is also equal to x because these are alternate angles. Why are they alternate angles? Because PQ is parallel to what? CA. But also A2 is x, and this is the Tan-Chord. Tan-Chord Theorem. Tan-Chord Theorem. The A2 is x by the Tan-Chord Theorem, therefore the P angle P is x because these are angles in Z because of the Tan-Chord Theorem. Right, we're good. So we have populated this diagram with the root of the x, 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 x. 1, 2, 3, 4. We found the 4 angles. So which means that we found x, 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 x. Okay. If this is true, then prove that ABPR is a cyclic quadrilateral. Prove that ABPR is a cyclic quadrilateral. Okay, here is ABPR. ABPR. Prove that ABPR is a cyclic quadrilateral. So what should we do? How should we prove this?
So we already have B and P equals to each other. We can say
Yeah,
they're in the same, we can say they're in the same segment,
yeah.
I think. And then yeah, I'm not sure after that.
Okay, that's fine. Remember, we are learning here, and we're taking our time to learn properly. Want to prove that ABPR is a cyclic quad. So to prove that ABPR, A, B, P, R is a cyclic quad, we can just prove that angle B equals angle P. Angle B equals angle P. Right, so we note that the angle B is equals to angle P. Why? Because it was proved in 9.2.1 above. Okay, because this one is x and that is x, so that the angle B equals the angle P, which is they're both equal to x anyway. It was proven there. Proved in 9.2.1 above. Moreover, therefore, okay, if this one is equal to this, then this shape resembles a bow tie. Angles in the same segment theorem. Okay, it resembles a bow tie, angles in the same segment theorem. As a consequence, we therefore can say, therefore, A, B, P, and R are concyclic. Are concyclic. Are concyclic.
So when you say concyclic, do you mean like converse cyclic quad?
Okay, by concyclic we mean that they lie on the circumference of the same circle. You know,
Okay.
your points are concyclic if you have A, B, C, D. So A, B, C, and D are concyclic, and the word con has to do with lying on the circumference of the same circle. Cyclic has to do with the circle, but con has to do with sort of common circle. Okay, right. So we continue. So that now A, B, P, and R are concyclic because we have that the B is equal to P, so that A, B, P, and R are concyclic. And therefore, if they are concyclic, meaning they lie on the circumference of the same circle, therefore ABPR is a cyclic. It's a cyclic quadrilateral. It's a cyclic quadrilateral. Why is it a cyclic quadrilateral? Converse angles in same segment theorem. Converse angles in same segment theorem. Okay, because now we have first realized that angle B is x, but also the angle P is also x, and it was proven, or it was proved in 9.2.1 above. A, B, P, and R are concyclic. A, B, P, and R are concyclic. Therefore, ABPR is a cyclic quadrilateral. ABPR is a cyclic quadrilateral. Converse angles in the same segment theorem. Angles in the same segment. Angles
Yes.
in the same segment. Okay, so yeah. So we've proven that ABPR is a cyclic quadrilateral. ABPR is a cyclic quadrilateral. We've proven that by proving that the points A, B, P, and R are concyclic points, and because we found angles in the same segment, and that meant that if we have angles in the same segment, then the 4 points involved are actually concyclic points. We prove the next question. Right, in the next case, you already know that this one is X, this one is X, this one is X, and that one is X. But also we know that ABPR is actually a cyclic quadrilateral with concyclic points. We need to prove now the proportionality. Here it comes again. Here comes your test. Something you love the most. So we need to prove that BA over BQ, BA over BQ is equal to BC over QR. Okay, the examiner twisted it a little bit. It's just a small twist because in principle you would expect BA over BQ because you are dealing with in triangle. In triangle, for instance, BQR. In triangle BQR, you then say like BA over BQ is equal to BC over, yeah, you take BC over BR. You take BC over BR. Okay. So now we're gonna actually realize that in triangle, BQR, BA over BQ is equal to BC over BR. Okay, and the reason for this is the proportionality theorem. The proportionality theorem. AC parallel to QP. AC parallel to QP. Okay, because AC is parallel to QP, then you use the proportionality theorem and say BA over BQ is BC over BR. This is the proportionality theorem. If you don't want to say proportionality theorem, if you don't want to say proportionality theorem, you say that line parallel one side, line parallel one side of triangle. In other words, you can say that reason or that, but we just can see the BA, BA, BQ, BQ, BC, BC. It's only the QR. So we're able to see that, but QR is equal to BR. But QR, right, QR is equal to BR. Why? Because this one is X and that is X. So this triangle is isosceles, this. X and X. So that you have the sides opposite equal angles. Sides opposite equal angles. Therefore, BA over BQ equals BC over QR. BC over BR. So BA over BQ is BC over QR. Over QR. Okay, so yeah, we use the proportionality theorem to write out the fact that BA, because now we have these two parallel lines, so that BA over BQ is BC over BR. But simultaneously, QR is BR. QR is BR. So that wherever there is QR, then it is equal to BR. With QR, it is equal to, wherever there is BR, we can put QR. Any question on this proportionality theorem results?
No, sir.
Okay, we move on to the next question. We move on to the next question. Okay, now, more often than not, you'll be expected to prove this theorem. So, in November 2023, they asked the learners this question in the November examination, you know. So they either ask you this, or they ask you this. So it can appear in the trials, it can appear in the thing, yes, please.
Sir, can we do proportionality questions after? Because I generally don't understand properly.
Okay,
I
that's
understand,
fine.
I don't understand. Yeah.
Okay, that's fine. Yeah, we shall do. We're just
I can do it after you explain. Well, after
yeah,
you
after
taught.
I explained this theorem. Okay, because you must just know how to prove this theorem. Right, and the theorem states that in the diagram, this is how the question came in the November 2023 exam of the students who wrote in November last year. In the diagram, ABC is a triangle. So you have ABC is a triangle. D and E are points on the sides. A, B, and AC. D and E are there. Use the diagram above to prove the theorem which states that a line drawn parallel to one side of a triangle divides the other two sides proportionally. That is proves that AD over DB is AE over EC. Okay, to prove this theorem, actually, we perform a construction. So to actually do this, you join BE and CD and draw H1. Right. So for example, you join BE and DE and draw H1 from what? And draw H1 from E perpendicular to AD and right and good. And H2 from D perpendicular to AE. All right, so you have this. You have that. Okay, so you have this. H1, H2. Let's look at the proof. Area. Triangle ADE. Area. Triangle BDE. Right, if you look at the area, so you actually construct the H1 from E that is perpendicular to AD, and H2 from D that is perpendicular to AE. So that the area of the triangle ADE is the same as what? Right, so you're going to look first at this side here, that is the AD. So you're going to have half AD multiplied by the height. Look at the AD, the height is H1. Right, divided by the area of the triangle BDE, which is half the base, BD multiplied by the height, H1. AD over BD. Area. Area triangle. ADE. Area triangle. DEC. Okay, now we have the other one, which is half AE. H2 divided by half EC. Okay, if you look at the triangle DEC is half base EC, the height is H2. Half and H2 cancel out, giving us exactly AE over EC. Just like that. Write the area. Triangle ADE is equal to area. Triangle ADE, right, at the top we have ADE, but the area of triangle ADE at the top is equal to ADE at the bottom. And this is just a common triangle. But area. Triangle BDE, area. Triangle DEC, same base and height. Same base and height. Okay, the area of the triangle BDE is equal to the area of the triangle DEC, because these two triangles have the same base, right? Have the same base DE and the same height. Same base and height. And moreover, same base and height is because these two triangles, BDE and the triangle DEC, lie between the same parallel lines, right? So DE is parallel to BC, like so. Now, if you look at this very carefully, what then we're able to observe is that area triangle ADE, area triangle BDE, area triangle ADE, area triangle DEC. Right, so as a consequence, we can say, therefore, that this area over area is equal to this area over area. And obviously, the top one is AD over BD. The bottom one is AE over EC. AE over EC, like this. And therefore, we have concluded the result. Any question? This is the kind of proof you'd be expected to do in the exam. So What do you think about the proof? Do you have any question about it? Because we expected to know this. It's
No, sir.
no. Okay, good. So it's there in the exam. It's there in the exam. So you must make sure you recall the proof. Okay, you remember.
Yes, sir.
All right, good. No question.
No question, sir.
All right. So now let's continue a little bit. Let's continue a little bit. In the diagram, O is the center of the circle. So where O is the center of the circle, use the diagram to prove the theorem which states that the angle subtended by a chord at the center of the circle is equal to twice the angle subtended by the same chord at the circumference of the circle. Right, is proof that angle top, angle TOP, angle top is equal to 2 times the angle TKP. So let's do a construction. Let's do a construction. So you draw KO and produce. So you draw KO and produce. Okay, this one you need to remember it also. Draw KO and produce. So you'd have to do this like that. Immediately, you're able to put 1, 2, 1, 2. So that the angle O1 is equal to the angle K1 plus the angle T. Exterior angle of triangle. Exterior angle of triangle. But the angle K1 is equal to the angle T. Angles opposite, equal sides. Angles opposite, equal sides. The angle O1 is equal to K1 plus K1, which is 2K1. The angle O2 is K2 plus angle P. Right, and the angle O2 is K2 plus P, exterior angle of triangle. Right, so obviously you have that. The angle O2, so this one here, you can say but. You can actually then come here and say but. The angle K2 is equals to angle P. Angles opposite, equal sides. So that the angle O2 becomes K2 plus K2, which is 2 angle K2. And therefore, the angle O1, right, the angle O1 plus the angle O2. What is the angle O1? It's twice K1 twice K2. And then you're adding O1, O2, but O1 is twice K1, O2 is twice K2. So you add them up. So it will be twice K1, K2. Which means therefore the angle TOP is K1, K2, which is 2 times the angle TKP, like that. Okay. Any question about this proof from grade 11?
No,
No
no,
question.
sir. I just have to remember it. Yeah.
Okay, yeah, you just need to remember it. You need to remember it because this is from a past exam paper. It's from a past November paper. All right, I'm looking at the time and we have gone a little bit beyond the time, meaning that
Yes, sir.
we're going to plan more. In our next discussion, we shall do more proportionality and similarity. Similarity and proportionality. Okay.
Sir.
Right, I must thank you for joining us. We're gonna actually let me see if I can get a homework. Okay, this one is gonna be a home activity. Right, so this one here is your home activity. Okay, I'm gonna send the recording after this. Right, so
Yes, sir.
in the diagram, O is the center of the circle. O is the center of the circle. A, B, C, D is a cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral. If angle O1 is 4x plus 100 degrees, the angle O1 is 4x plus 100 degrees, the angle C is x plus 34 degrees. Calculate giving reasons the size of the angle x. The size of x. Is it the size of x that appears in the 4x? It appears in the angle C. So it's 5 marks there, just a giveaway. And it was awesome time having this discussion. I can't give you so many homeworks. I have like tons of questions, but I'm sure we always have next time. Okay, at least
Yes, sir.
both exams. Right. Thank you so much. Until next time, take care and goodbye.
Thank you, sir. Bye, sir.
Thank you. Goodbye.